This is Algebra 2 at Trig, 1C.2b. We are going to solve quadratic equations by finding square roots or by using square roots. You can use square roots to solve some types of quadratic equations. Types without a b value. Those are the types that you can solve. Quadratics without a b value. You can use square roots with them. So your s value, or in this case, so you have your x squared equals a certain number. It has two real solutions to it. You're going to get a positive version and a negative version. So every time you take the square root to solve to get rid of your square, you have to use plus or minus, because there's two different ways that can be squared to get to your positive number. Let's come on and try it. So what we're doing here first is working with isolating the x squared. You want to get the x squared all by itself. So to do that, we are going to divide the 5. You cannot take the square root yet. So we have x squared equals 16. I'll write it again just for fun. So when we take the square root, you can see that that's kind of a second step. That's an additional step. And when you take the square root, you're going to get plus or minus 4. You get two different answers. Because up in your problem, if you plugged a positive 4, 4 squared is 16, times 5 is 80. Or if you plugged in a negative 4 and squared it, you would get positive 16 times 5 is 80. This next question, you need to think about what you would do first here. Okay, there are ways you could work with the 2 first. You would have to do all 3 terms. You definitely shouldn't just divide the 34. So instead of making those mistakes, I would suggest to move the 16 over first. Work with the like terms first. So now we have 50. We're dividing by 2 because you want to isolate your square root to get x squared that equals 25. And then when you take the square root of both sides, you get plus or minus 5. We can show the square root in there if you like. That gives you a positive 5 or a negative 5 when you come up here and square it, times it by 2, and subtract 16 should give you 34. Okay, you go ahead and think about this one. You can pause the video and come on back and see how we did. So here we're going to take our denominator and we're going to multiply both sides by 4, so we get 32. Then we'll take a square root to both sides, and we get x minus 6 equals. Whenever you take the square root, you got to use plus or minus. Then we took the 32 and we broke it apart. We broke it apart into 16 times 2 because we knew the square root of 16 was 4. And then when we add the 6 across, it does not combine with the 4, but it combines in front of the plus or minus, so this is 6, and you have plus or minus 4 root 2. Let's take another one. What's our first step going to be here? So the first thing that we're going to do here is collect our like terms. We'll add 6 to both sides. X squared over 25 equals 4. Then we're going to multiply by the denominator. When you multiply by the denominator, you're multiplying the top of the fraction. You don't multiply the bottom of the fraction, you're multiplying the top. It's kind of like 25 over 1. So you're multiplying the top, you're multiplying the bottom, but those cross out because 25 over 25 is 1. And this makes 100. X squared equals 100. Take the square root, and you get plus or minus 10. Don't forget your plus or minus. Whenever you take the square root, we can call it a square root. Whenever you take the square root, you're going to have a plus or minus, specifically if it's not a geometry or a time type question. In time, we're not interested in negative time too often. Geometry, you're not interested in a negative distance. Here's our story problem. This is just the rules behind the story problem. When we drop an object, reach out a window, drop an object down, something rolls off, we would have a formula of h of t, height in terms of time, equals negative 16. That represents gravity of how it's vertically pulling the item down. It will always be negative 16. T squared, because this is a quadratic. You can see in the picture that this would form a quadratic type shape. So T squared plus h of O. The h of O is your initial height, or the original height. So in terms of a formula to plug in your data, this would be your basic format. How gravity's pulling down the object, and how high was the object to begin with. Gravity's not changing, but the height can clearly change. When you look here, this is not the path of the object. The object is not getting farther away from the building. The object, in terms of time, when time gets further out, the object is getting closer to the ground, where in reality, the object is dropping straight down. Flip our page, and let's try one. Here we have a building. You're going to stand at the top of the building, and you're putting your hand out, and you're going to drop your water balloon right down the side. If you are 240 feet up, how long would it take that item to hit the ground? Like Mythbusters, we can do a calculation to give a pretty good prediction on how long that item's going to take to fall. So we're going to start out with our basic equation, negative 16 t squared plus h of O. So we want our height. How long will it take to hit the ground? So that the ground has 0 height to it. When, in terms of time, will we have a height of 0? We're using our negative 16. That's telling you how gravity's pulling it down. T squared, that's what we want to solve for. and we have 240 feet for our original height. We'll subtract the 240. So this is negative 240 equals negative 16t squared. Then we would divide by negative 16. That would give us 15 equals t squared. We can take the square root of both sides, so we have the square root of 15 equals t. So it's really the square root of 15 seconds. So the square root of 15 is 3.87. So 3.87 seconds is how long it would take for the item to drop 240 feet, assuming that you didn't have any air resistance on your object. Now, in terms of our taking the square root, you could think about a plus or minus on your square root, because every time we take the square root, we have plus or minus. But because it's time, we're not interested in a parabola that has negative time. We're only looking for time that's positive. Remember that this parabola that we wrote here is going to look something like that. So we're out here at 3.8, and we're back here at negative 3.8. So what's the time that it took the object to hit the ground? We're only looking at this x-intercept. We're not looking at that x-intercept. So that's why our time is only positive. We don't consider negative for time or distance. Looking at our next question, we have an equation, which is height. You could call it h of s if you wish, because the equation has s in it, but the height of our largest wave when the wind speed is s. So s squared times this coefficient tells us the height of the wave. So what is the wind speed for a wave of 20 feet? If it's going to take a 20-foot wave to cause certain damage, what does the wind speed need to be for that wave to occur? So we have h equals 0.019 s squared. We want to know about a height of 20 feet, and the S stands for wind speed, and it's the wind speed in knots. The first thing we would need to do is move the leading coefficient over. And to do that, we would use our calculator. 20 divided by 0.019, and that gives us 1052.63. That's s squared. And then we can take the square root of both sides. So we take the square root of our answer. Okay, notice I did not type in 1052.63. I typed in answer. It's a button on your calculator right there, so it's in blue, so I have to hit my second key first. Second, negative sign, so I get an answer. And that takes the previous result and calculates that out. That's minorly different as if you typed it in as a rounded number. So 3244. So the wind speed would have to be 3244 knots. That's no longer squared. All right, so far we have reviewed multiple ways on solving quadratics. We have used factoring. We have used solving with square roots. Theoretically, we could use graphing. When does it cross the x-axis? That is another way. So depending on how the equation is written, you're going to solve it differently. So I look at this one here, and I notice there is no b value involved. So if there's no b value involved, I can divide to isolate my x squared. Now this is probably a problem. I see a lot of people make a mistake and they divide by the 2. They bring the 2 to the other side because 18 divided by 2 is 9. And then you magically put an equal sign in between the 9 and the x squared. You can't do that. You have to move the coefficient away into the denominator. So we're stuck with 2 over 18. So now I'm going to take the square root of both sides, and I get plus or minus square root of 2 over the square root of 18. The square root of 18 is 9 times 2. So I'm really going to have plus or minus root 2 over 3 root 2. So when I rationalize my denominator, I get plus or minus 2 over 6. I wasn't expecting that. Which simplifies to 1/3. We can test this, and now that makes sense. I guess if you think about your answer, 18 times 1/3 squared. Square 1/3 and you're going to get 1 over 9, and 9 goes into 18 twice. Or if you want to say 18 times negative 1 over 3, and you square it, and you're going to get 2. So in both cases, that works out. I got the 6 from 3 times root 2 times root 2. I had to rationalize the denominator.
Why do you multiply by square root of 2?
One question was, could we have reduced our 2 and the 18 to have gotten 1/9? And that's x squared equals 1/9. Then when you take the square root, you got to take the square root of the top, and you got to take the square root of the bottom, which is still 1/3. We're going to get the same answer as long as you do the problem correctly. So either way, that's a good way. I just went about looking at the numbers we had in front of us. All right, let's take a look at letter B. So try to make a decision here. You can pause the video, turn it back on, let us talk you through it. First thing we'll do is divide by 2. We have x minus 8 squared equals 44. Now I have something being squared. There's nothing else I can move over. You cannot move the 8 over. So the best I can do is take the square root of both sides. So that's x minus 8, because taking the square root of something squared, you're going to get the value inside. And this becomes plus or minus 4 times 11, because that's what 44 is, 4 times 11. So we have x minus 8 equals plus or minus 2 root 11. And I add the 8 across. Don't get that 8 mixed up with the 2. The 8 stays separate from the 2. So we have 2 root 11.
So if 44 was a perfect square, would you just take
And last question is now to slide over here to this question. What's different about this one? It is quadratic, but actually all of these are still quadratic because they all have an x squared. This has a b value as 2 different types of x's. So I'm going to add my 15 back to this side, because if I have a b value, then I have to make it equal to 0. And then in a guess and check type format, we're going to come up with 2 numbers that multiply to be 2x squared if you were foiling to make this. The only options there are x squared and x. 2x, sorry, this is 2x times x. Then we're limited on the options for 15. 5 and 3 or 15 and 1. 15 and 1 seem pretty darn big, so I'm going to try 5 and 3. So 5 and 3, if this was a 5, that would be 10, and 3 is going to be 13. That didn't work. But if you put a 3 here and the 5 on this side, this is your guess and then check. You have to take the time to check it to get 6 and 5, which is your 11. There's your 6 and 5, which is 11, and then your 15. So now I know that my FOIL worked. So these have to both be positive to get a positive 11 and a positive 15. So then I'm going to use the zero product property to set both my factors to 0, subtract across my 5, divide by a 2, and subtract a 3.